And these aren't, the questions you ask about 14, 15, and 16, they are not on your exam.
Oh, really?
No, they're in your homework, but there's no questions like that on your exam.
Okay.
But we'll go over them because they're actually very, very easy
I'll still write that one.
to look at. Yeah, you want to make sure you write them on your homework. So, okay, so what we have is we have this equation. And if we read the directions here, we're not going to be solving this. It says, find the discriminant, okay, and then use that to decide if they are rational, irrational, or non-real complex. So what we're going to look at is we need to get this set up to use the quadratic formula. So we have to make sure it's set to 0. So we're going to move that 3z over. And then we need to make sure that it's in the correct order. So 6z squared is your highest power of z, so it goes first. And then we have a 3z. And then we have a plus 1, and that equals 0. Now we're going to go ahead and find our a, our b, and our c, just like we would to use the quadratic formula. So a is 6, b is 3, and c is 1. And we're not going to solve this because on these, all we need to do is find our discriminant. And our discriminant is b squared minus 4ac. And we'll plug our values in. And we'll calculate it out here. And that should be a 24. And 36 minus that 24, that leaves you then with a 12. So there's part of it. You need to find your discriminant. Okay? And then we use this discriminant to determine the number and the type of solutions here. So what we're going to now look at is we're going to look at this table from our textbook. So on these, we're not using the complete quadratic formula. All we are doing is determining the number and the type of solutions. And this is actually, and I know we talked about it last time too, this is actually on page 138. Remember this table? I'm sure you probably do. Yep. Okay, now, when we worked out our discriminant, which was here, we got our discriminant to be 12, didn't we? So, how many solutions do we have and what type? Well, when we look at it, we're looking at 12. Okay, 12 is positive. Is 12 a perfect square? No. Okay, so it's positive but not a perfect square, so that means we have 2 irrational solutions. And that's all you have to write on it. So we have 2 irrational solutions. So we're not solving these. All we are doing is determine the number and the type of solution. So 2 irrational solutions. What about 15? 15 is the same basic type of question. And on 15, we've got t squared minus 8t plus 16 equals 0. We're not going to solve this again. All we have to do is determine the number and the type of solution. So, is it set up to get your A, B, or C? Is it in the correct order? It's set to 0. Yes. Okay. So in that case, there's no number in front of our t squared, so we're going to put a 1 here. And so our A is 1, B is going to be a negative 8, and C is 16. And our discriminant is B squared minus 4AC And that is a negative 8 squared minus 4 times 1 times 16. Okay, you with me so far? Just plugging the numbers in, right?
Yeah.
And negative 8 squared, well, that's a positive 64. And then a single negative, that keeps that negative here. And 4 times 16, well, that should be a 64. 64 minus 64 makes it then a 0. Now, when we go look at our table again, we go back and we look here, what do we know? We know our discriminant is 0, right? And how many solutions do we have? From our table, one solution, and it is rational. So we have one rational solution.
I think I was not here for this because I don't remember this at all. I think this is the day that I had my sonogram.
And you might very well have been gone that day.
I guess we should have looked at the note.
But they're easy to go through.
Because it seems like really easy.
It is. It is. One more just to make sure we have these down. So question 16. We've got 2y squared equals a negative 6y and a minus 7. So same procedure. Now before we do anything with these, what do we always do? We have to set them equal to 0, right? And these are out of 1, 4. We're going to look at the practice exam next, and then the take-home final as well. So we're going to go ahead and set this to 0. So we're going to add the 6y and the 7. And that gives us then 2y squared. We've got a 6y and a 7. And we're checking our discriminant, right? So A is 2, B is 6, and C is 7. And our discriminant is b squared minus 4ac. So we plug in our values here. And 6 squared is that 36. And 4 times 7 is, 2 times 7 is 14. And 14 times 4 makes it a 56. And 36 minus 56, that's a negative 20. And what do we now know? Well, we know our discriminant is negative. So if we look back at our chart, it is negative. So it says we have 2 non-real complex solutions. So it's negative. So you have 2 non-real complex. Okay, and we can add more to the list on the practice exam. We were going to look at 4, 7, and 10. So if we've got any more, we can add more to the list. Do we come up with any more? Yes, we will. Yep,
Okay,
yep.
I forgot my calculator.
Yep, no problem. We're going to take a break once we finish working through these. And again, our exam today is going to be, there'll be 22 questions. You're going to be able to skip 2 of them. And they're going to be a combination of the practice exam and the take-home exam. Mostly from the take-home exam, but there are a couple of questions I picked from the practice one as well. But you'll be able to skip 2 questions, and there's going to be 22. Do we have any more to add on the practice exam? Okay, yep, we'll look at those. We got 4, 7, and 10. And then we'll look at those take-home exam questions as well after that. So let's look at our practice exam. And we're going to look at question 4. Okay, so let's see what we've got here. So for question 4, this is a mixture question. And there's one kind of similar to this on your exam today. What we're looking at is we're looking at mixing acid solutions together. So how much pure acid should be mixed with 8 gallons of a 50% solution to get an 80%? So since we're mixing chemicals together, we'll represent these with containers. And I always label the containers 1, 2, and 3. And each of these containers has an amount and a percentage rate. And the first part says how much pure. Sure, yep. Okay, so that's what we've gotten so far. And this one says, and I know we set it up last time, I believe, but we'll finish it out today just to make sure we get the correct answer. So it says how much pure. So we don't know the amount. That's going to be X. And the percentage rate of that pure is 100%. We are then going to mix it with 8 gallons of a 50% solution. And we want to end up then with an 80%. So this is what we want. Box 3 is always what we want. And we add, so that's going to be an X plus 8 there. Okay. Now we build our equation, and our pure is the amount times the percentage rate. Our first one, 100% is 1, so we don't have to write the 1 down there. So 1 times X is simply an X, right? Those get multiplied together. On the second one, what do we have here? 50%, 8. So 50% is 0.5. The amount is 8. And what does that then equal? 80%, which is 0.8. And how much is in there? X plus 8. Are you with me so far? And that's box 3. Does that make sense? Okay. So now what we're going to do is we're going to go ahead and distribute this 0.8 through. Combine like terms, so that gives you an X, and half of 8 is 4 on the left-hand side. Distributing through, that's 0.8x, and 8 times 0.8, I believe that's 6.4. Yep, that's going to be 6.4. And we'll move that 0.8x over. I'm going to put a 1 here in front of that x, just so remember it's 1x there. And so we'll move that 0.8x over. And that 4 will go over as well. So be careful with your decimals. Students tend to make a mistake with the decimals, so 1 minus 0.8, that's 0.2x. The 4's, they cancel. The 0.8x's, they cancel. And 6.4 minus 4, well, that is 2.4. We'll divide by the 0.2. And that gives us our final answer then of 2.4. Divide that by 0.2. That is 12. So what do we now have? We now have 12, and these are in liters, I believe. Oh, gallons. Sorry about that. So 12 gallons of pure. Okay with that so far? Does that one make sense in how we set it up?
Yeah.
Okay. And if not, just be sure and ask, because I can go over it in more detail. Okay, so that was that one. And now we'll look at 7. 7 is going to be on your exam today. Different numbers, but it's one of the choices out of the 22. So question 7 is on there. Because when I made up the exam, I made sure I put this one in there. It's a pretty easy question. Numbers are different. That's the only difference here. So, what do we have? We have a bookcase. And we're going to take lumber, And we're going to build this bookcase. 1, 2, 3, 4. And when we read this question, it says we're going to build a bookcase as shown below. The height of the bookcase is 4 feet longer than the length of the shelf. Okay, so your height is going to be the shelf length, right, plus 4. And we don't know the length, so we're going to call the length of any of the shelves x. And now when we rewrite them, we get the height to be x plus 4, and we get the length to be x. Are both of you okay with that so far? Right? Now, we are now going to label it, and then we'll talk about that 20. On your exam today, it might be something different. I think it's 24 or something like that. The numbers are slightly different. Same concept, though. So when we go to label this, what do we have? Well, we've got the two sides, and they're x plus 4 and x plus 4. And then we've got 1, 2, 3, 4 of those. Right? Those are my lengths there. Make sure we got the same as the figure. 1, 2, 3, 4 of those. Yep, the two sides. We know our total is 20, and that was given in the question. Okay, so this is from the problem. And what is that 20 going to equal? That 20 is going to equal the total. And so if I sum everything up, then I have x plus x. We got 4 of these. Plus, and you can write them out as 4x, so you can just write them all down. We're just adding them all up. Plus x plus 4. Plus x plus 4, and that's going to then equal 20. Right, just add up all the sides here. We got 4 x's, and then an x plus 4, and another x plus 4. And it looks like we have 1, 2, 3, 4, 5, 6 x's, so that's 6x. And 4 and another 4 makes it a plus 8. We'll move that 8 over. So 6x equals 12. Divide by our 6. And so now x equals 2. Okay. And we need to make sure we completely answer the question, because this is only part of it. It says find the length and the height of the unit. So let's talk about the length. Okay, the length is going to be x.
So it'd be 6.
It'd be 2, wouldn't it? Right, because we got 12 divided by 6 makes
sorry,
it 2.
I was
Yep.
looking at the height.
Yep, no problem. So the length is 2, and you can do them in either order. It doesn't matter. And the height is 2 plus 4, which is then 6. And these are in terms of feet. So the length is 2 feet, and the height is 6 feet. You will see a problem very, very similar. And I made sure I picked this one because this is a good one to have on your exam. I know it's on there. I can't even remember which questions, but it's on your exam. Different numbers, different order, same figure. One more to look at. Question 10. This is an easy question. Students tend to make a mistake on this one, but it's very, very simple. And we're going to go over it and make sure we see where the mistake is. So on your practice exam, we've got question 10. Now, we are going to use this formula. I equals P R T. P is a starting amount or the principal. R is the rate as a decimal. And T is years, not months, years. And I is, of course, the interest that you get out. or that you are charged. So in this case, we're getting charged from the bank some interest. Levi borrowed $4,532. So my P is going to be $45.32. And he's borrowing that at a 6% interest rate. And we convert that to a decimal. And so as a decimal, that's 0.06. So make sure you use the correct number of zeros. We are not borrowing this loan or writing this loan for 6 years. We are writing it for 6 months. So 6 months, we're going to have to divide this by 12 because there's 12 months in a year. And that gives us then our 0.5. Is everyone okay with how I got the pieces? So when you encounter a question like this on your exam today, make sure that if it's in months, you divide it by 12. And if it would have been like a third, you're going to have to keep the fraction and divide at the end. This one is a half. Half is a rational number because it comes out to be 0.5, so you don't have to worry about keeping out extra places. So let's go ahead now and multiply these together. So our interest is going to be $45.32. We're going to times that by 0.06 and 0.5. Multiply all those together. So 45.32 times 0.06 times 0.5 for the half of a year, right, the 6 months. And that gives you then 135.96. So that's your interest. So your interest is going to be $135.96. And your total then is going to be your $45.32 plus $135.96. And that then gives you a grand total of $4,667.96. So there's your interest. And there's how much you have to pay back. Okay, are we all right with that? And so this is a very easy question. We need to make sure we understand how to do one like this. The most important takeaway here, though, is make sure that if it's in months, you divide by 12. Any others on that practice exam to look at? Anything else? Okay. On the take-home exam that I gave you, I'm not going to work these complete. Well, 5 and 6 I'll work out completely. 12 I will set up. Well, actually 12 will go through. It's easy as well. So this is going to be our take-home exam, and we can add more if we need to. But we'll start with these. Now, I will tell you that 5 and 6 are the easiest questions on your exam, and I want to make sure that we get these two right, because these are going to be on your exam. Different numbers, same exact type of question. 5 and 6, I picked those out. Those were on there. I picked them out this morning when I was making up your exam. Different numbers, of course, but they are on there. Now, what are we looking for with this one? I give you this number, negative 10. Now, we need to identify what negative 10 is. So our choices are complex, pure imaginary, and non-real complex. Is it this one? No, why not? Because for it to be complex or it to be pure imaginary, what do we have to have? We have to have an I, right? Okay, they're not there at all. It's not just complex because negative 10 is also what? Real, right? So all numbers are complex, but then below that they're either non-real complex or they're real. Okay, so this negative 10 is real, and it's not non-real because if there was an I, then it would be non-real, right? Non-real complex. So what is it? It's B, because it is real and it is also it is real and it is also complex. Everything is complex, and then they're also either real or non-real complex, no matter what. So do not miss that one. What about 6? Well, 6 is 9 minus 6i. So what do we know about this? 9 minus 6i. Well, we know it's at least complex, right? Is it real or is it non-real? Non-real. Is it pure imaginary? Pure imaginary would mean you didn't have the 9 in front. So pure imaginary would be like a minus 6i. Well, it's not pure imaginary, is it? So it is what? It is non-real complex, and it is also complex. So it would be answer D. Do we need to come up with another one? You want to do another one so we understand this? Okay. Because I do not want us to miss these. We'll do 2 more. So here's another example. What if I gave you 8i? What would 8i be?
Oh, that'd be the pure imaginary.
Right? And what else is it? So it's everything is always what? Complex, no matter what. It's also non-real complex. And then you also told me that it is pure what? Imaginary. What about minus 1.9? What would that be? Minus 1.9. Is that real or non-real?
Real.
Real. So if it's real, what else is it?
Complex.
Okay, so it's real and it's complex. And one more. What about 8 minus 2i? What would it be? Real or non-real?
Non-real.
Non-real. And what else is it following it up?
Complex.
Okay, so it's complex.
That's not complex.
Yep, complex and non-real. Complex. Yours will be a little bit easier because you have the choices there. There are 2 questions. I changed numbers. I picked these because I want to make sure we have some easy questions. Those 2 are on there as choices. So do we see what the 3 different cases are?
Yes.
So it's either going to be real and complex, which is something like negative 10 and negative 1.9. Or it could be non-real complex and also complex, like these 2. Or it could be something where it is pure imaginary, non-real complex, and complex. We also asked about question on our take-home exam here. We also asked about question number 12. Yep, we can add 10 on there as well. Yep, I'll add 10 also to that list. Okay. Sure, we'll add 10 there. We'll do 10 first then. How about that? Chuck and Dana agree to meet in Chicago for the weekend. Chuck travels 144 miles in the same time. Now here's the important part. Same time. Dana travels 124 miles. If Chuck's rate of travel is 5 miles per hour more than Dana's, and they travel at the same length of time. So that's the important key there. Same time. At what speed does Chuck travel? So let's draw our arrows here. They're both going to Chicago. And we've got Chuck and we've got Dana. So Chuck, his distance is 144. Dana's distance is 124. Chuck's rate of travel is 5 more than Dana's, so Dana's rate of speed is unknown, and that's going to be an X there. So we can see what we've got. So Dana's rate of speed we really don't know, so we're going to use an X for that. But what about Chuck? Chuck's speed is 5 miles per hour more, so his is going to be R, equals now X plus 5. And the key component here is the times are the same. Now, when we look at our distance formula, the distance equals the rate times the time. And if we solve this for the time, we now get the time, t, is going to be the distance over the rate of speed, right? Okay. So that's what we're looking at here. We have to use the time, and we know the times are the same. So we know Chuck is going to equal Dana on the times. And we're using this formula, distance over the rate. So Chuck's rate of speed is 144, distance is 144. His rate of speed is X plus 5. Dana's is 124, and her rate of speed is unknown with it being X. So now we're going to go ahead and cross multiply here. And I'm guessing the mistake is probably in the very last step, because you probably found Dana's speed instead of Chuck's speed. So let's go ahead and cross multiply. And that's going to give you 144x equals 124 times x plus 5. And if I'm going too fast, just be sure and say something. I can slow down a bit and we can talk about things. Distribute that 124 through, and that is 124x. And then 124 times 5 should be, 62, I believe. Or no, 620. I was thinking of 0.5, so distribute that through. That's going to be 620 equals 144x. We'll move that 124x over. And now we've got 20x equals 620. We'll divide by our 20. And that gives us now x equals 31. But that's 31. That is Dana's speed. So Dana's speed is that 31 miles per hour. But we don't want Dana's speed, do we? We want Chuck's speed. And Chuck's speed is going to be x plus 5, and that's 31 plus 5, which is then 36 miles per hour. So it's going to be 36, not that 31. Does that make sense now? And that's probably what you did, was you got Dana's speed, and if in doubt, just get them both. If they're both on there, and you want to do them both all the time, that's fine, because as long as they're both on there, I'll give you full credit. If you just write down the 36, you'll also get it. So just make sure somewhere I see that 36, and you would get full credit for that. One more to look at, and then we'll take a short break, come back and take our exam, because I believe question 12. And on question 12, we're going to try to solve this. And remember, there are 3 different types of equations. And let's talk about the three different types of equations that we can encounter. Okay, what can we encounter? We can encounter conditional. Conditional means there's a condition or a number that makes it work. So if you solve it and you get a number out for x, that's a conditional equation. You then have a contradiction, which means you end up with something that is a false statement, like 8 equals 20. 8 does not equal 20, so that's false. That's a contradiction. If they match up exactly on both sides, that is an identity. So identity means they are the same. Relate that to identical twins. That's how I remember. I think of contradiction as false statement, because that's like lying in court. I think of identity as identical twins. They are the same. So we go ahead and distribute that 5 through. Let's see what we've got here. So 5 times 2 makes it a 10x. And then 5 times that negative 31. That's going to come out to be a minus 155. And what do we know here? These are exactly the same, aren't they? Right? If they are exactly the same, we don't have to do anything else. If they are identical on both sides, this is an identity. And what's the solution set for the identity? Well, the solution set is all real numbers. So that's what I'm going to be looking for on that question 12. Is notice that it is an identity, and your solution set will be all real numbers. Okay, so let's go ahead and take a short break. That way we can get up and walk around if we need to.